start streaming so people can watch on the Twitch channel. And I'll turn that off to decrease the background noise because I only just got home and it was cold. So there we go. And go into here. Now it won't be as easy for me to see you because I'm only operating on a single screen. Today I'll be on dual screen next week, and yeah, so it should be the week after as well. Okay, so good morning all. I will be talking about some design patterns today, and we'll go into some of the documentation and how to document the games that you're making. Also, happy for you to interrupt me and ask me questions. We'll then go into my 6Animal deeper into the group formation and group analysis stuff. Or if you want, we can skip straight to that. So put stuff in the chat and I'll go and have a look at it as we go through. So can I get an indication of how many of you have done design pattern work in your second and third year courses? So you've done some software engineering design patterns, things like singletons, those ideas that there's a design that tells you the kind of framework, the template for solving a problem. It doesn't give you exact code for the problem, but it gives you this idea of how you would solve the problem in a sort of general framing. So for example, the singleton, the trick there is that you get a pointer to a static, and the idea that when you want something, you either get a pointer to the one that exists or you create it. If you've got lazy instantiation, you create that and then get a pointer to it, and you make the creation secret so that people can't accidentally create a second one, right? So it's this idea of shielding creation so that it's not possible to create competing things that you need just one of. And so in game programming, you have all of the standard programming patterns, but you also have what we consider design patterns. So these are solutions that have happened in games that are interesting for game developers and interesting patterns for people making games, but may not be true for every software engineering practice. So in terms of design patterns, we have the programming patterns, which hopefully you've seen in other courses. Usability patterns, which if you've done a user interface course, there is a collection of human-computer interaction patterns where we look for standard ways of solving problems of interaction. So, for example, one of the standard patterns is a shield pattern that when you are about to do an irretrievable, an unreversible action, you pop up a modal dialogue to warn the user that what they're about to do cannot be undone. Given that, you know, there's this kind of feeling of usability that you do something, you can undo it, you can go Control Y. So a standard pattern is to say, well, when that's not the case, you need to warn the user, right? So this is this idea of design patterns. In games, we also have... Sure. Yep.
If you're sharing your screen, we can't see it on Discord.
You can't see it on Discord. Ah, okay. That doesn't help. Okay, so let's go back to Discord and go down. Sorry, I'm obviously in the wrong place. Thank you for interrupting. Share screen and go for that one. Okay, because I can share screen even though there are 25 of you in here. I just can't share video, I think, when there are more than 25. Right. Thank you for interrupting. Is that better? Just asking the Discord. We have... Yes, great, fabulous. Haha, back to here. Okay, so So I'll show you the screen. So that was the start screen. We then had the design patterns, so software engineering design patterns. A design pattern is not a finished design. It is it's a transferable template, and that's what singleton pattern is. And then we go into these programming patterns, usability patterns, and game patterns. All right, so that was where I was referring to those user interface patterns, and also the singleton pattern, programming patterns. Okay, so when we look at game rules, and game design, there are people who have been working through this idea of like how do we define what are the design principles? What principles should we use? And if you look at things like the theory of fun, this was Ralph Koster's book that he wrote from a lecture he gave. He gave a lecture. People really liked the lecture. They liked the framing, and so they asked him to write a book. And so there is a book on the theory of fun, which is by a game designer about game design, because there is a distinct difference between us academics and actually I'll just check. Am I sharing? Yes, I am sharing the right thing. Oh, wait. Am I sharing? Yes, I am sharing the whole screen, so you are seeing that, so that's fine. I'm sharing, that window, yep, that's good. So a theory of fun, and he goes through and in the book talks through how he's come up with this theory of what makes things fun, right? So you can go through and follow through the slides and follow the descriptions, or go and purchase the book. But the summary of all of this is that so there's also the Hal Barwood and Noah Felstein took over, kind of trying to enumerate all of the design rules, and they got to 112 and then kind of didn't keep going. And Jesse Schell has the Book of Lenses, which is this idea that as a designer, you are you know that you can't think of everything all at once, and so what you do is you take different perspectives on the game you're making, so that you can focus your mind and just look for those components. Now, the kind of highlights from those sessions, and part of my job is to highlight what's going on. Choice is very important in games, right? So games are about choice, and we talked about this when we defined what a game was, is that games are about making choices. Now, once you start thinking about those choices in the games you are making and designing right now and starting to flesh out, you want to be talking about things like balance. How do you make those choices interesting? Magnification. When I make a choice, I want to have an outsized impact on the world, or an outsized impact on the environment. I know my kids were annoyed when I first took them out with an axe and was trying to get my son to cut down an actual tree, because the Minecraft world they lived in had lied to them about how hard or easy that was. And so there's like, if you actually had to spend the time to cut down a real tree, as in the game would be too slow, right? But by magnifying the impact you have in that virtual world, people feel better about that interaction. You also, when you have choices, you think about what are the consequences for those choices, right? So, and what amount of risk are you taking? If in your game you have no consequences for a choice, then it kind of doesn't matter which choice the player makes, because it's all the same. If every choice is the same, so if I offer you 10 kroner in my left hand and 10 kroner in my right hand, which one do you pick? It's kind of, well, doesn't matter, 10 kroner, right? It's the same amount of money in each hand. If I offered you an Xbox versus a PlayStation, that might be an interesting choice. It's somewhat balanced, but it also has different considerations, because there's a whole bunch of considerations about the ecosystem and about the kinds of games you can play and the controllers and the features, and there's a lot of other decisions, other factors that come into that decision. We also, when giving people choices, you can also think about the amount of risk that they're taking, and is there a safe option versus a high risk, high return versus low risk, low return option. So there's this idea of thinking about what choices your players are making, because those choices are the core of your game, right? So for each of your games, I want you to think about when is the player making a choice? When is the player exerting some ability, right? Is that choice strategic, as in it has consequences beyond the current 5-second scenario that I'm in? Or is it tactical, as in it changes my current posture? It changes what I'm doing immediately, right? So how much, and you don't have to have all of the layers of choice. Sometimes a game can be just tactical, right? It's all just in the moment, what you're doing now, versus strategic, where an action I take now will have an influence later. But I want you to think about those choices as you design your games. There is a pattern of mastery of simple patterns, right? So this idea of puzzles, or some first-person shooter games have this idea of I'm creating a sequence that has a kind of right answer. There's a puzzle, there's a simple pattern to find, a simple pattern to solve, a simple puzzle, and there's fun in puzzles, right? So there's this concept of I want to do puzzle finding because, or puzzle solving, because it has a definitive end, it has a clear pathway. Some of my players will be puzzle solving players, right? There are a whole set of rules around social interactions, right? So I'll just finish the previous thought. In your games, I want you to discuss what are, if there are any puzzles in the game, are there simple things that the player does where there is something they have to figure out or something they have to work through that has some sort of right answer, or is identifying a simple pattern, or recognizing something going on in the world, and think about how hard that might be. Social interactions, we have a whole bunch of ways in which you build societies around your game. So PvE and PvP. So PvE is you're just killing enemies, but PvP, you are fighting humans. Generally, we have some standard design processes around that. One is it is useful to provide some of your players with a player versus enemy, a PvE style environment, and not just throw them straight into PvP, so that at least some of those players get an idea that they can test themselves out, they can experiment, they have a low risk scenario where they're not risking social status in trying something and practicing something. And then you have these PvE where you have ELO ratings and you have ways of matchmaking. In the early days of games, matchmaking was a real problem, and you'd have really strong players on an environment with very weak players, and it wasn't fun for any. Well, it was fun for some of the strong players because they just liked to dominate and kill everybody, but for most of the noobs, it was a bad idea, right? And so it's actually a really important design principle around how you manage matchmaking in PvP. Clans are a way of creating teams and creating that sense of belonging. It also extends your game life by having senior people mentoring junior people within a clan. So it's within a structure that is identified within the game. We also look at ways you can build cooperation as well as competition, right? So PvP is competition, and where you have teammates and clans tend to be on that cooperation side. In games, we also provide ways to create and to explore the world. So in your games, again, when you are thinking about what features your game have, one of the lenses and one of the ways of thinking is, how does my player express themselves in the game? Some games that had didn't have any social signaling and had no social interactions, people started doing crouching as a sign that I'm a friendly, right? And then once people started doing something as a sign that they're friendly, then other people did that to troll people, and it becomes a nightmare. But are there ways that you can express yourself in the game? And, you know, going like doing dances, crouching, other movements that some players might use as social expression, some people will use to try and be creative in your game. Also, what is your player exploring? Is it just a blank world where there's nothing to see, or are there different areas, different things to be engaged with, different parts of the game that are interesting? So those are some of the highlights. I like to dig a little bit into balance and chance, because most of you, most humans are very bad with understanding percentages. Actually, the people in this room, programmers and maths grads, tend to be better at understanding random distributions than the general public, but many people still struggle with how ideas combine. Right? So when we start looking at dice rolls, right? When you roll a six-sided dice, you get a linear distribution, 1 to 6. When you roll that dice a second time, you get a distribution between 2 and 12, but it's not linear. Right? Adding two linear distributions together doesn't give you another linear distribution. It gives you a wee pyramid, right? Where the 2 and the 12 happen once out of the 36 possible rolls, and 7 occurs, I think, 7 times out of the 36 possible rolls, right? So you get this weird pyramid shape. Now, that idea of how do we manage randomness and how do we deal with that kind of normal distribution from combinations of linear sampling? How do we, when you're designing your game, thinking about managing randomness? Now, some of you, and I'm just trying to think if any of you have a zero randomness, so a purely deterministic game. I think most of you have interactions that might be non-deterministic. So, if you are going to use randomness, then we need to talk about how terrible humans are at understanding randomness, and look at designing different ways of dealing with randomness. Right? Now, there's a couple of standard ways of thinking. Design patterns are ways of thinking about this. And if we kind of try and understand how humans are struggling with this, it is like you understand identical independent distributions. So when I flip a coin, it's independent. If I have a very large bag of black and white beads, and I pull a white bead out, and I count out that's one white, and I put it back in, shake up the bag, and I pull another bead out, then I'm still at 50-50, right? And if I got a black bead, a black bead, a black bead, what would be your prediction of the next bead I'd get? No, it's probably 50-50, right? Because you think, well, you know, there's still 5 black balls and 5 white balls, so there'll be 50-50. If, however, as I remove the white balls, I keep them in my hand, after getting 3 white balls in a row, what does that mean for the number of white beads and black beads left in the bag? Right. After taking out 3, I've got 2 white beads and 5 black beads, and that leads to this idea of there being a 70% chance of getting a black bead. Now, if we were in that standard situation where we had 70% black and 30% white, if I was to pull out a random bead, how many of you, what percentage of you would guess that it would be black? Right? If I'm sitting in a situation with 2 white balls and 5 black balls, I'm hoping, fingers crossed, all of you would suggest black. Right? We have nobody who's written black, bright black, or white. But the thing is that if you saw a black bead and you imagine that you're putting them black in, if you had a 70% chance and you went black, next one 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 black, at some point you might go, I know 30% of them white. Some point it's going to be a white one. And then you would try and second guess the distribution and go white. That suggests that you have this bag in your brain, that you're not treating events as being actually independent and identical. You are treating them as dependent in this way, where I've taken out a bead and then and that changes the distribution in the world, right? And so you can kind of work out where your players sit in the number of beads in their mental model. You might often find they're around sort of between 5 and 10, right? Is that a lot of people, if they're guessing a 70-30, will guess the larger one for, 10 or 15, and then they'll try and second guess it and pick the other one. If there hasn't been one of the other ones just recently, if there's been a run of the same thing, they think, well, it's got to come up shortly. Right? So anytime there's that long run, what's interesting about human intuition is that as soon as you see, in this case, if you're thinking there's 70% black, as soon as you see the white bead, you can kind of reset and go, okay, we've now reached the equilibrium and we'll go back to being 70-30. So there's this kind of odd understanding of how this works. Now, for some people with a very small bag of mind, they would pick, if they saw heads, 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 they're going to pick that the next one's going to be tails. Right? If you'd been guessing like heads, tails, heads, tails, heads, and you'd seen head, 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 many people go, oh, it's got to be tails this time. It's got to be tails this time. Right? Which, actually, if you were flipping a coin and you got 5 heads in a row, you might predict that it's going to be heads because it seems to be an unfair coin. Right? So estimating probability is something that humans are terrible at, and we're making games for humans. Right? So the reason to manage randomness is because it is our players that need to understand this. One of the interesting things you can do is if you've ever played Catan, so hopefully some of you are board game players and have played games like Catan, there you roll 2 6-sided dice. There is actually a whole set of Catan dice cards, and actually I'll see if I can, let's see if I can go into here and go Catan dice cards. I should have that. So Catan dice cards, right? Cards or dice. So let's see, can I find them? Oh, there is also a Catan card game. But these, I think, are the ones I'm looking at. That's the dice game. No, that is the dice game. What they do is they have cards that are 1 through 36 cards, I think. Can I find it with those? No, those are odds dice. Dice odds. So what, and I'll have to go and find them and point them out to you, but there are a deck of cards with the numbers 2 to 12 on them, and there are 36 cards in total, and so they give a perfect distribution of all of the rolls that you could get with 2 6-sided dice, and they make it exactly the distribution. And the design pattern here is that if you want fairness in your random numbers, don't just go rand 0 to 1, right? Because that you're right, that's very easy to do. It is the simplest way of generating randomness, and it will be unfair, right? What you could do is get a run of, if you wanted percentages, and it's going to be between 0 and 1 or 1 to 100, generate 100 numbers, right? Generate the 100 numbers between 1 and 100, or then divide by 100. So it's like you have 1, you have 0, you have 0.01, 0.02, 0.03. So you make that list, and then you randomize the order of that list, and then you present that list by picking the first item out of the list, so that you are pulling randomly, so that by the end of 100 you have exactly the right distribution. Now, some people would say, well, okay, that's fine, except that becomes too easy to predict, and so another way is to say, well, we'll do that for the first 50 out of the 100 throws. So we'll randomize it, and you'll get the first 50 will come from this, and then we'll re-randomize, right? And it's kind of, okay, that seems fair, right? I'm keeping it within a band, and so there's this idea of random order rather than random number as a design pattern. There's another design pattern where what you do is to drive the mean always back to what you want it to be. If you wanted the center to be 50%, right, and you're trying to get numbers on both sides, every time you have a number lower than the mean given back to the player, you increase the chance of a number on the other side of the mean being rolled, right? So what you do is you shift the mean towards that number, and then increase the size of that side of the distribution, so that what happens is, as small numbers pull you this way, you're more likely to get large numbers, and that will pull you back, right? So there's this idea that you are correcting the randomness and shaping it to be closer to the distribution that people think it is, or that they would like it to be. Now, Civ used this in I think Civ 4 battles or Civ 3 battles, where you had 2 to 1 odds, and like 3 to 1 odds. If you ever lost a 3 to 1 odds contest, which 3 to 1 means out of the 4 possibilities, 25% of the time you lose. Right? That's what 3 to 1 odds mean. Most people don't really understand odds, and so what they found is that for 4 to 1 odds, you always win, right? Because once you're at 4 to 1, you've got an 80% chance of winning. Everyone believed that when they lost to 4 to 1, that was unfair, right? And so the game, although the game said 4 to 1, it now treated it like 100, right? So it just capped it. And also, if you lost a 3 to 1, so with the 25% chance of losing, you lost, like you have 3, they have 1, you lost a 3 to 1, your next 3 to 1 odds, instead of that being random and having another 25% chance of losing, so this would happen 25% of 25%, so you get a quarter of a quarter, which is a 16th. So about 5% of the time, sort of 6% of the time, this would have happened. What they did internally within the game is that if you competed in a 3 to 1, you would lost, you would always win the next 3 to 1 odds ratio. So they didn't have the game as actually random. They had the game tuned so that people would feel that it was fair, not random. Okay, so what I want you to take from that is that there's these ideas of how to balance. Interestingly, with AI now, what you do is when you want to think about these things, ask the AI not how do I do this, but ask it what are my options for creating balance in my game using a random number generator. What are some of the different ways game designers make sure it feels fair, right? So what you're doing there is you're triggering the AI into the space around fairness, around game design, around number generation, and so it then gives you a response, and it will highlight a bunch of standardized patterns, right? The challenge is you have to know that that whole space of discussion exists, and B, you have to work out whether or not it's making sense in the examples it uses. For balance, there will be a lot of discussions on difficulty, on choices, on fairness, on skill versus strategy, on length versus rewards, on freedom versus scripted things. There's lots of balancing, and a design principle is finding balance. Right? So that's one of these design patterns that we talk about, is the pattern of finding balance. You want your players to feel your game is fair. Right? If your players think your game is unfair, they'll often stop playing. You can make a game unfair. So one aspect of a game being fair is that players with a similar ability should have a similar chance to win at the start of the game. Right? So there's this idea that if a game is fair, then you and I both have a reasonable chance of winning if we have similar abilities. If you're much better at the game, then it's probably okay that you're more likely to win. So what we do is we try and find ways to make games more fair. Fairness mostly applies to, again, the startup of the game. So the principle here is that you need to think about, when the player starts, how do they feel about the game? Do they feel like there's a reasonable chance of them doing well? Or do they feel like, oh no, there's no point, I'm going to lose? So to achieve some of this, games often think of these symmetry kind of activities. So chess has symmetry in the pieces. It has some asymmetry, as there's a black piece and white pieces, and the white pieces get to move forward first, and so you still often has a little bit of asymmetry still there, but you try and find ways to create symmetry. And then we have asymmetry, where this can be a bit tricky because asymmetry is naturally unbalanced. And so when you look at Hnuftafl, the Viking game, it is an asymmetric combat game with different objectives. And so it's harder to balance because you can't just give everybody the same pieces and expect them to then fight it out. You're saying, okay, you've got different pieces with different objectives. How do I make sure that there's a reasonable chance for white to win and a reasonable chance for black to win? Right? So this is, again, the design lens of creating an interesting, balanced, strategic or tactical choices that result in enjoyable gameplay. One way of doing this is Terry Pratchett, one of the Discworld author. He made a game called Thud, which was dwarves versus trolls, and explicitly in the rule set he said he's not a game designer, and so he had a two-phase system where you first played as the dwarves and then you played as the trolls, and then you'd sum the score from the two games together to see who wins, because he couldn't work out how to make the game fair for both players so that they had the equal chance of winning. So he just said, well, play it twice, one from each side. Unfortunately, there's still asymmetry there, because going first, you then know what your score is, and so you've got a better idea of how you manage the progress towards that score. No? So if I'm second, I can know that I have to score 25 points, and so that might change my decisions. Another way of setting up balance is using spreadsheets, and here we can set up this idea of having an idea of how valuable something is. So if we have jeeps, APCs and tanks, a fairly standard thing to do in games is you create the spreadsheet of those, and you estimate the quality, that might be a word like low, medium and high, and then you give that an estimated number of how important it is. And then you move across and you say that's for armor, that's for weapon, that's for speed. That will give me some sum across those scores. And then I can give a price, which is probably negative, for the value of those items, right? So this tries to give balance so that, because tanks are, given the score of 11, better than Jeeps, if tanks and Jeeps were the same price, you would just buy all the tanks, right? So you need to make tanks more expensive. How much more expensive? Well, you work out how much each of those is valuable. And then what you do is you watch people play and you try and estimate and update the weapon value, right? So we say that the tank has a good weapon. Actually, people are still winning a lot with the tank, so let's increase the value of a high-powered weapon. So that goes from 6 to 7 to 8 to 9 to 10, and that raises the price, right? And so you're trying to work out how to balance that. Oh, another design principle saying that if you had your tank weapon damage and you said that its value is 6, if you think that's too low, don't do what I just said. Absolutely don't make it 7, right? Because if it's currently 6 and you think it's too low and you make it 7, then suddenly you go, oh, it's still too low, I'll make it 8. Oh, it's still too low, I'll make it 9. Oh, it's still too low, I'll make it 10. Oh, right? Why are you moving it by such a small amount? There's an idea that in games, when you're trying to estimate a balance for a system, doubling and halving. So what you do is with 6, you go, let's double that, right? So let's try it on 12. Let's try and get on the other side of the scale. So we say, well, 6 is too low and 12 is too high. Because if 12 is still too low, you double that again and make it 24. And go, okay, well now, is 6 too low and 24 too high? And maybe 12 is now too low, right? So you try and double. And then when you see that you've got, once you've got, like if you started with 24 and it's too high and you halve that to 12, right? You then got this idea of, okay, I now know what's too high and I know what's too low. So now I pick the center of those two and start searching using a binary search to get down. So I have the gap to keep moving towards the actual number. Okay? So that's our standard search pattern in this kind of scenario. Right? So it's called doubling and halving. And so that's how you do this search through your playtest to make those modifications. Right? And certainly you know that once you've found once too high and too low, standard pattern is a binary search. Check the middle. If it's too high, move smaller. If it's too low, move right. Right? Very standard things. Right. Rock paper scissors is now. I was mentioning rock paper scissors to one of the students, and they were saying that we've got a rock paper scissors game kind of going. This is my rock paper scissors lizard Spock game, and I don't think I had gone through this with you guys yet, but you can play the international rock paper scissors competition. They've taken away. You can play rock paper scissors against each other with the rock paper scissors game, and this is resolve online or send them a link, and you can or play with a random stranger, and so it's a standard rock paper scissors game. All right, so there are various ways you can play this online, and I haven't added this rock paper scissors to our Discord this year. I don't think have I left the rock paper scissors on the Discord? Is there the RPR rock paper scissors bot? What have we got here? So, I think there is an RPS bot in the room. If I go back to the room, have we got the bot that is the rock, paper, scissors bot? I can't see him on there, but you can. There is a Discord bot. I've got the roll bot. I don't know if I've been able. There he is. Yes, there is the rock paper scissors bot in the chat, so you can actually go into Discord and choose to play rock paper scissors in the Discord, right? Because we've got a rock paper scissors bot in the Discord with hash rock paper scissors channels on Discord and RPS play. So you'll find that there is a where did I put the rock paper scissors channel? RPS channel. Oh, I didn't got there. I'll have to reset up his text channel for you to play rock paper scissors with him and with each other. The idea of rock paper scissors is when you are then playing with balance, what you can do is you can do things like increase paper by 1. You put that into a spreadsheet and you look at, okay, paper versus rock gets me 2 points. Rock versus paper, rock gets 0, paper gets 2. Right? Rock versus scissors, rock wins with 1 point. And so you look here and rock gets 1 point in winning and loses 2 points. Paper wins with 2 points and loses with 1 point. And scissors remain 1 and 1. And so you still have a sum of 4 by 4. So every person has the same possibility, but now we've got this asymmetric decision about risk taking. Right? So it's not perfectly random. And you might then decide, okay, well, we're going to have a rock and paper both get +1. Right? And so that then creates a new asymmetric balance, that rock and paper are stronger than scissors, so scissors become the weakest throw. However, there is still some level of balance in the game, right? So you can think of those as those options. And I have this whole rock, paper, scissors AI system where you put in the rate of the points and then you let the AI learn how to play. So we can dig into that later if you guys want to. So is a game deep, right? Is your game an interesting game to play after time? Super balanced games tend not to be deep games, right? They tend to feel like none of my choices matter because it's just random who wins or loses. So for a game to be deep or interesting, you need to start creating these longer term strategic decisions, right? So there needs to be some sort of complex relationships between options. If we look at poker, back in the 90s, the casinos changed the poker that you see on television from stud poker to Texas Hold'em. The reason they did that was because Texas Hold'em, they always win, right? Because there is no gameplay, there is no card play. You don't change anything about the cards in the game, which means it's completely deterministic who's going to win. From once the deck is shuffled, you can then look at the deck and know exactly who has the best hand, because no one can make choices about who has the best hand. The only choices you make are about betting and staying in, right? So they become the social meta game around social betting and trying to work out how much risk someone will take based on the unknown nature of the cards that haven't been turned over yet and the cards that are in other people's hands, right? It also meant that because the house isn't making card play, the house doesn't actually compete. The house always just takes a cut of the pot, and that means that when you cheat in Texas Hold'em, the only people that lose are other human players. Right? And so that then becomes what we think of as another design pattern, is when you have competitive play and people are cheating, how do you make sure that you don't lose, right? That the house doesn't lose, that the game is not broken. And so sometimes you give the players the responsibility to catch cheating, right? So it's this kind of how do we design around someone breaking our game. We also have this idea of ending quickly. So if you're building your game and you have a situation where one group is going to win, one person's going to win, try and create a positive feedback loop so the game ends quickly once someone gets an unassailable advantage. Yeah? Or create rubber banding so that no one has an unassailable advantage. So rubber banding is a wee bit controversial. If you played Mario Kart, for example, the rubber banding means that when I'm at the back of the field, I get extra speed and the pickups are extra powerful. Now, if you make your rubber banding too strong, what people do is they hold back from the start for the first few laps to let someone else get a lead and then be hammered by all the negative feedback, and then they race through on the last lap after the front people get smashed. So if your rubber banding is too powerful, then you create that unfortunate situation where people are gaming the start. I think the most impressive version of that, of rubber banding, is the Olympic sport of track cycling, where the rubber banding is if you are behind someone, you get to draft off them, and then come up to the last track, you draft, and then you pull out and you overtake, because you can pick up speed behind them faster than they can pick up speed. And so you see at the beginning of some of the track cycling races, everybody traveling very, very slowly to avoid being the first person and getting the negative feedback of all of the wind. And the last example of some of the balance stuff that I'll talk about in this idea of lens of fairness is Magic the Gathering. So in Magic the Gathering, there are many bad cards, right? And they have not been balanced well. So even if you don't balance your game well, you can still have a very popular game for other reasons. And these are all the reasons he explained why there are bad cards in Magic the Gathering. But hey, that's okay. We let people know, people work it out, people adjust their play, they'll ban some cards, they'll not play some cards. So there is players who work that out. Now, what I'll do is there's my doubling and halving. I will now take a break because it's 9 o'clock, and we'll come back and I've got a whole bunch of stuff here that we can talk about, but I wanted to get on to, and I've got them here, these documents and potentially some discussion on types of fun. Okay, so I'll just stop at the moment and we'll give you guys a chance to ask any questions. If I go back to the room. Oh, I mean the room that I'm actually in, so I can get to see the chat. So, are there any questions in the chat? Okay, I can't see any questions in the chat, but we'll take a 15-minute break and we'll come back and we'll talk documents, and if I get time we'll go back to discussing balance and fairness. The principles of balance and fairness are the main thing. It's not any specific detail that I want you to understand. I want you to get this idea of trying to find balance, this idea that your players need to make choices, the idea that your players need to have some progress through the game, and they need to be by either thinking strategically or tactically, or that there is a skill element that you're testing, right? So thinking about your players and thinking about how they interact with the game. Okay, so we'll take a quarter-hour break and we'll be back at 9:15. Think of some questions to ask me. Okay, so we'll leave a break and I'll be back shortly.